The least common multiple is a number that we want to find in a lot of situations. In particular, we use least common multiples when we're working with fractions, and you'll remember them more likely as least common denominators, or LCDs. But the least common multiple of two or more numbers is simply the smallest number that those numbers will divide into evenly. So for instance, if we consider the two numbers 18 and 24, the smallest number that they will both go into is 72. And we can see that by simply writing the list of multiples of each number. So for instance, the multiples of 18 are 18, right? 1 times 18, 2 times 18 is 36, 3 times 18 is 54, 4 times 18 is 72, and 5 times 18 is 90. And of course that list could keep going, but these are the multiples of 18. Then if we write down all of the multiples of 24, they look like this. 1 times 24 is 24, 2 times 24 is 48, 3 times 24 is 72, 4 times 24 is 96, and so on. So if you look at both of those lists and then simply find the smallest number that is on both lists, in this case 72 is on both lists and it's the smallest number, that is the LCM. That's the smallest number that both 24 and 72 go into. And so that's an important number. For instance, if we had two fractions and one of those fractions had a denominator of 18 and the other fraction had a denominator of 24, and we were trying to add or subtract them, we would first find the least common denominator, which is the least common multiple, and that would be 72, and then we could do our work with those. But we want to find the least common multiple of numbers. Now in this case we only found the least common multiple of two numbers, but if you had 3 or 4 numbers, you'd do the same thing. You could create the list of multiples of all 4 numbers and then find the smallest number on that list. But that's kind of a lot of work. There's a more methodical way we can do it using prime factorization. Because you'll remember that the prime factorization of a number is kind of breaking the number down into its most constituent parts. So if I want to use the prime factorization method to find the LCM, I'm going to first find the prime factorization of each of our numbers. So 18, it factors into, let's see, 2 times 9, 2 times, and then 9 factors into 3 times 3, right? So there's my 2 times 9. 2 times 3 times 3 is of course 18. That's the prime factorization of 18. Now do the same for 24. It's going to factor into, you could do it a number of ways, but let's say 4 times 6. Well, here's 4, right? 2 times 2. And then 6 is 2 times 3. And so those are the prime factorizations of 18. Okay, so once again, what we're doing here is we're finding the LCM by using prime factorizations. Okay, so the first step in that process is to find the prime factorization of your numbers. So that's what we did with 18 and 24. And then you look at those prime factorizations. And notice there are some 2's and some 3's in these. And so we know our least common multiple is going to have some 2's and 3's in it. Alright? Well, how many of these is it going to have? Well, the rule is this. You find, let's just talk about the 2's for instance. Find the largest group of 2's. Well, this number has a single 2 in its prime factorization. This number has 3 2's. So that is the biggest group, that set of 3 2's. So our LCM is going to have 3 2's. So we'll take that group of 2's. Okay, so we're going to take the largest group of each different kind of number. So we take the set of 3 2's, and then we talk about 3's. Well, look at the groups of 3's. There's 2 of them here, there's 1 of them there. So the LCM is going to have the largest group of 3's as well. In other words, it's going to have that pair of 3's. And so we take our 3 2's and our 2 3's, and that makes up the prime factorization of our LCM. So if we multiply those together, we're going to get the LCM, and if we just take a quick look, we see, hey, that's an 8 and that's a 9. 8 times 9 is 72, and there we go. So that's the way to find the prime factorization of a couple numbers, or even 3 or 4 numbers. You do the same thing. So let's see it done with 3 numbers now. Here we have 3 numbers, 8, 18, and 30, and we want to find the least common multiple of these 3 numbers. So let's use our method of prime factorization. So we're going to find the prime factorization of each number. 8 is 2 times 2 times 2. 18 is 2 times 9, 2 times, there's my 9, 3 times 3. 30 is 6 times 5, so 6 is 2 times 3, and then times 5. That's my 6 times 5. So now look at all those numbers and notice there's some 2's, there's some 3's, there's some 5's. So we're going to want 2's, 3's, and 5's in our LCM, and so we know we're going to take, let's start with the 2's, find the largest group of 2's. Well, here's a group of 2's in that number, there's a group, and there's a group. Well, the largest group has 3 2's in it, so our LCM is going to have 3 2's in it. So there's our 2's. Now look at the 3's. Look at all the groups of 3's. There's a group and there's a group. Well, what's the largest one? It's a group of 2 3's, and so our LCM is going to have 2 3's in it. And then finally 5's. Well, we only have one group of 5, and so that's by default going to be the largest of the groups of 5, and so we're going to take that. Largest group of 2's times largest group of 3's times largest group of 5's. That looks like that's going to turn into what? This is an 8, this is a 9, and this is a 5. And if we multiply those together, we should end up getting 360 as our LCM. So 360 is the smallest number that 8, 18, and 30 all go into.